Alright, in this video we're going to solve another quadratic trigonometric equation. So it's quadratic because there's a square term. So one thing to notice here is you've got two trig terms, a secant and a tangent, which is a bit of a problem. You need to do something about that. You can't solve a trig equation if there's two different trig terms, and they're two different types of trig terms, unless you can common factor, which in this case you can't. So we're going to have to change one to the other. And the way you're going to change one to the other is using an identity. So you have to find an identity which relates secant and tangent. And the identity we have is that secant squared of theta is equal to 1 plus tan squared theta. If you're not sure why that's the case, remember we have sine. That comes from the fact that sine squared plus cosine squared theta equals 1. And if you divide everything here, if you divide by cosine, I did this by cosine squared, this by cosine squared, and this by cosine squared, you would get sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. So we have this identity, which was up here. You don't need to prove this every time. You should have this as a known identity. So we're going to substitute this in to secant. Then we will have 2, 1 plus, or tan squared plus 1, minus 3 plus tan theta equals 0. So now I have only tangent terms. I can expand to tan squared theta plus 2 minus 3 plus tan theta. So now here it's one where it's like a quadratic. I'll add the like terms, and I'll put it in the typical order of a quadratic, descending powers. So now I'm going to think of this as a quadratic equation which I have to factor. I won't make the substitution in this one. If you want to make the substitution, you can, but I won't. So I know that I'm going to have a 2 and a 1 as my leading coefficients because there's a 2 there. So tan theta and then 1 tan theta. So 2 tan theta and 1 tan theta. And then the last terms multiply to give me minus 1. So it's going to be 1 and 1. And one of these has got to be negative. And it's going to be this one. The reason it's that one is because 2 times 1 is positive 2. 1 times minus 1 is minus 1. And when I add those numbers together, I have to get positive 1. So that's where the negative has to go. And now I'm just going to set each bracket equal to 0. So tan theta equals minus 1 here, and then over here tan theta equals 1/2. And we will solve for theta. Now in this case, tan theta equals 1/2 is not a special angle. So you have to use your inverse tan function on your calculator. So inverse tan of 1/2 or 0.5. You'll get, making sure your calculator is set to radians, 0.46. Now tangent is positive in the first and the third quadrant, and this would be the angle in the first quadrant. 0.46 is the related acute, so you need to find the angle in the third quadrant, which also has a related acute of 0.46. So you will add pi, so or theta equals pi plus 0.46, which would be approximately 3.6. And then over here, tan theta equals -1. That one actually is a known angle. So theta is equal to, so tan theta equals 1. If it was 1, it would be pi by 4, but it's negative, so you're going to be in the second and the fourth quadrant. So in the fourth quadrant, that would be 3 pi by 4. 3 pi by 4 is the angle with the related acute of pi by 4. And then in the fourth quadrant, you would get 7 pi by 4. So it would be 2 pi minus pi by 4. So you get those 4 angles. So therefore, theta is approximately equal to 0.46, 3.6, and then these ones are actually exact, but 3 pi by 4 and 7 pi by 4.